Hello students, welcome to physics classes. In our previous lecture, we had learned about the center of mass and its linear momentum relative to center of mass for n particle system. Today, we will discuss about angular momentum of system of particles. As previously we had discussed about the linear momentum. So as we consider a frame of reference, this x, y, z, and there is a system of n particles, namely particle 1, 2, 3 and so on. Let us suppose there are n particles, and these particles, first particle has mass m1, second has m2, third has m3 and so on mn, and their position vector relative to collision is r1, r2, r3 and so on rn respectively. Suppose at this point the center of mass of the system lies. So its position vector with respect to collision is as always denoted by capital R. Suppose we are interested in the ith particle, so that it will be ith particle whose position vector with respect to collision is Ri. And position vector of ith particle with respect to center of mass is R I prime. So now, for this n particle system, we are interested to find out the angular momentum of the system. So by definition, we know the angular momentum L of the system is R cross P. P is the linear momentum. As we are interested in ith particle, so angular momentum of ith particle, let it be Li, is Ri cross Pi. Ri is the position vector of ith particle and Pi is the linear momentum of ith particle. So Li is angular momentum of ith particle. So total angular momentum of the system with respect to origin is sum of linear momentum, sum of angular momentum of all the particles. So it is summation I equal to 1 to n, as it is an n particle system, Li. It will be summation I equal to 1 to n Ri cross Pi. We can write it with the help of equation 1. So let this total angular momentum is represented by capital L. Don't confuse it with this equation. This was just definition. Let it be question number 2. Now, this Pi is, as in our previous lecture we had discussed, MI, linear momentum of ith particle whose mass is Mi and velocity is Vi. And we can write L equal to summation I equal to 1 to n Ri cross Mi into Vi. This is equation number 3. We had rewritten equation 2 with the help of this Pi. From the diagram, vector Ri is vector R, capital R plus Ri prime, that is from triangular addition. So it is required for us Ri, and Vi is also required. So we will differentiate dRi upon dt with respect to time. So it will be dr upon dt plus dRi prime upon dt. So this is velocity of ith particle with respect to origin O. So it is Vi equal to capital V, velocity of center of mass, plus Vi prime velocity of ith particle with respect to center of mass. So let us assume these two equations in question number 3. So n will be summation I equal to 1 to n. Ri is r plus ri prime cross mi. Vi is capital V plus Vi prime. So we can rewrite this, simplify this equation as summation I equal to 1 to n mi r cross v from first term, from these two terms, plus summation I equal to 1 to n r mi r cross vi prime, plus these two terms we have summation I equal to 1 to n mi r I prime cross mi into v, plus summation I equal to 1 to n. From these two terms it is r I prime cross mi vi prime. So we have simplified this equation. So this equation can be written as r cross v summation I equal to 1 to n mi. And this equation can be written as summation I equal to 1 to n r cross mi into vi prime plus summation I equal to 1 to n. This equation can be written as mi ri prime cross v plus summation I equal to 1 to n. We can write as mi ri prime cross mi vi prime. As in our previous lecture we have discussed this mi vi prime. This is 0. This is the linear momentum of system of particle with respect to center of mass. Vi prime is velocity of the ith particle with respect to center of mass. So we are talking about the linear momentum of ith particle with respect to center of mass. So it is 0 as we have discussed in our previous lecture. So it is 0. So this equation can be written as summation 1 to n mi, that is sum of the masses of all particles in the system. So this is always represented by capital M as we discussed in previous lecture. So this is total mass of the system into r plus v plus this term is 0 plus this term is also 0. Why this term is 0? This is mi into ri prime. The first movement of the mass of the system about center of mass, which is also 0, plus this last term is summation I equal to 1 to n I cross this mi vi prime is linear momentum of the ith particle with respect to center of mass. So finally we have this as r cross m into capital V plus summation I equal to 1 to n r I prime cross p I prime. So this mass into velocity of center of mass, this is linear momentum of center of mass, which is cross product with capital R. Capital R is the position vector of center of mass with respect to origin. So that means it is the angular momentum of center of mass with respect to origin. So let it be denoted by L prime plus this is angular momentum of the ith particle with respect to center of mass. So it will be, let it be LCM. This is the total angular momentum of the system. So Here L prime is the angular momentum of center of mass with respect to origin O, because it is cross product of R into total mass of the system multiplied by velocity, which is the velocity of center of mass. M is the total mass of the system, plus this LCM is, which is the angular momentum of the system relative to center of mass. That means the total angular momentum of the system of particles about the origin O is equal to the sum of angular momentum of center of mass relative to origin and angular momentum of all the particles about the center of mass, because it is summation term. So it is angular momentum of all the particles, sum of, and the angular momentum vector L depends on the origin O, because it depends on R. If center of mass lies at origin O, then this R is 0, then this term is 0. But if the center of mass is at rest, then vector L becomes independent of origin O. So this was about the angular momentum of system of n particle system. In the next lecture, we will discuss about the kinetic energy of n particle system. Please like and share the video with your friends and subscribe the channel. Thank you for watching.